Assalamualaikum and hi, I'm Shikin Aziz. Salts in food factory are unwanted materials which may contaminate the food products and affect the product quality, reduce the process efficiency, unpleasant view, and many more negative effects. In previous video, I have explained inorganic salts. In this video, I'm going to describe organic salts in food factory. Organic salts can be classified into several classes. Food deposits, right? One of it is food deposits. The primary source of food salts deposit are from the food product being handled. For example, food residues or deposit that may form during food production. Okay. For example, in this photo, it shows the tomato residues that splash from tomato puree processing line. Okay, you can see some of the food residues here, right? And this part as well. Okay, it doesn't look good, right? Then petroleum. Another organic salt is petroleum deposit. For example, lubrications. Okay, lubrications oils, lubrication oils here, right? Grease, right? And other lubrication products. Non-petroleum deposit, for example, animal fats, and vegetable salts and vegetable oils, yeah, and vegetable oils. These organic salts may also classify into several component types. This includes proteins, carbohydrates, starch, oils, fats, grease, and microbiological films. Protein-based salts are derived from food protein ingredients. Protein-based deposits are the most difficult salts to remove in food industry. Generally, removal of protein-based deposit needs high alkaline detergent with peptizing or dissolving properties. Sometimes wetting agent, okay, wetting agent can also be used to increase the wettability and suspendability of proteins. In addition to wetting agent, alkaline cleaner with hypochlorite is used to clean protein film. Protein-based salts are slightly acid soluble, all right? It's slightly acid soluble. It's water insoluble, and it is alkali soluble. Protein-based salts can range from simple protein, which are easy to remove, and to very difficult to remove due to heat denaturation. Due to heat denaturation. And carbohydrate-based salts in food industry is mainly derived from sugars. Simple sugars are easy to remove as it is soluble in warm water. So basically, carbohydrate can be water soluble, and at certain condition, you need as well alkaline. It is only alkali soluble. So for example, like for starch residue, some mild detergent is needed to remove starch. But if starch associated with protein or fat, thus highly alkaline detergent must be applied. Sometimes prolonged heating process can cause caramelization. Okay, caramelizations. hence increase caramelization, okay, and hence increase the difficulty of cleaning process. Fat-based salt is usually rinsed away with hot water above the melting point. But for difficult fat and oil residues, alkaline detergent need to be used. Eh? Alkaline detergent need to be used. Preferably detergent with good emulsifying or saponifying ingredients. If the temperature of the cleaning solution falls below the melting point of the fat or grease or the fat globules, then the grease will deposit, especially on plastic hoses and gasket. When oils and fats are heated, polymerization occur. Polymerized fat will deposit on the surfaces, causes gum formation, which are difficult to clean. Food salts are the more salts that will be deposited in the food equipment, preparation and production area. The challenge with food salts are once it dries, it will form a hard film, and when heated, the deposit will harden even more. Thus, it is important not to delay the cleaning. Food salts are complex. For example, actually this photo is a photo of strawberry ice cream, right? It contains a mixture of several components like protein from cow milk, carbohydrate such as sugar and liquid syrups, and fats. This show that generally salt in food industry contain mixture of several composition, and there is no single detergent that capable of removing all the salt type. Another troublesome salts in the food industry is biofilm. Microorganisms which include bacteria, yeast, molds, and molds. Alright, and it can produce sticky secretions, uh, which is invisible films on surfaces. This film allow for microorganisms to glue onto surfaces. Common affected surfaces are at any surface which liquid flow stays stagnant for a moment, or when Reynolds number reduce from turbulent to laminar flow. For example, the internal surface of processing equipment, such as pipe, tanks, mixers, grinders, slicers, hoppers, stuffers, and cooling towers, external surface of fillers, tunnel cooler, dead space, porous or cracked surface irregularities, like the gasket. And then at the conveyor also, it's common to find biofilm and packaging equipment, especially at product lines, fillers, tanks, right? And then the reselection of the bottle washer. Biofilm formation can be divided into 5 stages. The formation begins with a reversible attachment of the planktonic cells, followed by adhesion to the surface. Then the bacteria form a monolayer and irreversibly attach by producing an extracellular matrix, which are polysaccharides and glycoproteins. Next, a microcolony is formed, where multi-layer appears. There is a multi-layer. During later stages, the biofilm is matured, okay, forming characteristics of mushroom shape. Right, these mushroom shaped structures due to the polysaccharides And finally, some cells start to detach, and the biofilm, okay, start to detach. Okay, start to detach, and the biofilm will disperse into the environment and potentially start a new cycle of biofilm formation. And this photo highlights the generalized stages of the biofilm cycles within a pipe. As the distance from the wall, okay, as the distance from the wall, this is the pipe. This is the pipe, and this is the magnifying area of the pipe at this cross section. Okay, this is the magnification. All right. So when the distance from the wall increase, which is the middle of the pipe, for example, the flow becomes laminar. More of the flow has become the laminar. This illustrate the profile of the laminar flow. Okay, close to the wall is a bit. You might see the flow is more turbulent. Alright, except for the boundary area. Okay, alright. So then, at this area, the region 1 degree here is basically where the primary adhesion happens. And then at the second area here, where this is called secondary adhesion. Okay, so it becomes thicker, the flow becomes thicker. And then this green triangle here, NG stands for nutrient gradient. So this nutrient gradient concentrate within the biofilm. Yeah? And then the PI here stands for protozoan interaction. Alright. And then the C, where is the C? Here. C that happen on the surface of the stainless steel or the surface of the pipe. Alright. Corrosion of the pipe surface might happen. Alright. And then the E is the erosion, okay, where biofilm gradually damaged and removed by the liquid flow. And then S here stands for sloughing, sloughing, where some layer of the biofilm come off. Alright. So this is actually what is illustration, illustration for the biofilm inside the pipe, inside the flow channel. Microorganism film is difficult to remove. Okay, to remove microbiological film, often cleaners as well as sanitizer with strong oxidizing properties are needed. Alright, the most effective chemicals to break the biofilm is peracetic acid and sodium hypochlorite solution. Removal of biofilm will be more difficult when they are hardness deposits. Inorganic salts like hardness deposit can protect other salts. For instance, biofilm and food salts by making their characteristic more complicated. So important to note also, improper use of detergent can actually set salts, making them more difficult to remove. Thus, it is essential that staff involved with cleaning have an understanding of the nature of the salt to be removed before selecting a detergent. Okay, that's it for now. And thank you for watching. See you in another video. Bye.